Hey guys, this is part 2 of our lesson on graphing quadratics in vertex form. We've already done number 1 and 2, and now we're going to knock out 3 and 4. Again, the beautiful thing about vertex form here is that you can look at it and tell the vertex immediately, because the vertex is the opposite of this one, comma, that one. So that's why the vertex is going to be -2, comma, -1. Opposite of this one, and then that one stays the same. Let's put that right in the middle of our chart. So -2, -1, there's the vertex. We could graph it too. -2, -1. Now right now you should know whether or not this parabola is opening upward or facing downward. See how there's no negative in front of here? There's no number visible at all. That means it's a 1. But because there's no negative, that makes this a positive 1, a value. So we know that this parabola is an upward facing parabola. Alright, just trying to make a few connections with you guys. Alright, so anyway, this is what we have so far. As far as other x values, going less than -2, we have -3, -4. Going greater than -2, we have -1 and 0. Alright, this is the point at which we employ the TI-30 XS multiview. Let's see, x plus 2 squared minus 1. Hit your table button. Open parentheses, x plus 2 close parentheses squared minus 1. Double check, x plus 2 squared minus 1, x plus 2 squared minus 1. I find hitting enter 5 times does it. 1, 2, 3, 4, 5. Okay, so here we are. Now our table starts at an x value of -4, so I'm just going to scroll to that. And we have 3, 0, -1. Okay, so 3, 0, and there's the -1 that we knew. Because of the symmetry of a parabola, we know that this y value will be 0, like this one, and this will be 3, like that one. But it's fun to just scroll down and observe your predictive powers. So there's 0 and 3, just as we knew they would be. Now we can graph the rest of these. So -4, comma 3. Okay, -4, 3 would be right there. -3, 0. That's right on the line. And there's our vertex. And then the symmetry kicks in, and you can see why these y values repeated, because -1 is back to 0, and then 0 is back at 3. Okay, you can see how each point has a mirror image. Okay, at this point we could draw the parabola, okay, using these 5 points as a guide. I always like to see if I can get one more value out of this chart though. And I can, okay, I could get another point, 1, 8. So please, even though these are all the values that were required, if you can find an extra value, go ahead and do it. So we've got 1, 8, a bonus value. So 1, 8 would be right there, which means there'll be a mirror image of it right here. Okay, it just makes your graph more accurate. So always graph as many points as will fit on your grid. Alright, so there's our parabola. Make sure your graph goes all the way to the edge like this. If you really want to be cool, you'll put some arrows on the end of it to show that it goes forever. But at the very least, make it go to the edge of your graph. And that sort of implies that it goes forever as well. Okay, what else? The axis of symmetry is a vertical line that goes right down the middle. We like to draw that as a dotted line. Axis of symmetry, here it comes. Alright, so there's your axis of symmetry. Now we can answer these questions. The vertex, well, we've had that for a while. That's -2, -1. What about this vertex? Is it a maximum or a minimum? Well, you see it's at the bottom of the graph, so that makes it a minimum. Does the parabola face up or down? We discussed that. We knew it would face up because it is a positive a value, and sure enough, it faces up. The axis of symmetry is this vertical line down the middle of the parabola. Vertical lines always have the equation x equals some number. This is a vertical line at -2, so it has the equation x equals -2. So that's what I'm asking you for when I ask for the axis of symmetry. Notice that the axis of symmetry and the x value of the vertex are the same number. That's just common sense because the vertex is always in the middle of the parabola, and guess what? The axis of symmetry is always through the middle of the parabola, so they will always have that same x value. But by the way, when you write the axis of symmetry, you have to write x equals -2. Don't just put -2. It's the equation of a line, and just putting a number is not the equation of a line. Now, zeros are the x-intercepts, and these ones are really clear. Sometimes we have to estimate, but we have -3, 0 and -1, 0. These are the two x-intercepts. So -3, 0 and -1, 0. Now the y-intercept is 0, 3. Alright, the y-intercept is always 0, something. If ever you don't see it on your chart, just look for it on your calculator. Go to 0, that'll be your y-intercept. Now the domain. The domain represents the x values of a graph. So because of that, you ask yourself, how far left and right does the graph go? So parabolas such as these always have the same domain because they all go left forever and they go right forever. So we will write -infinity to +infinity. Similarly, the range is the y values represented by the graph. So we ask ourselves, how low does the graph go and how high does it go? And you do need to give me the range in that order. It's got to be from bottom to top. It's always least to greatest. So the bottom is -1, and then it goes up forever. So -1 to infinity for the range. So -1 to infinity. Infinity always gets the round parentheses, but this -1 will get the square bracket to show that -1 is included on the parabola. The parabola reaches and touches and includes -1. You can see that -1 right here in the vertex. Alright, so it's definitely included. Whoops. Alright, anything else? Domain, range? Nope, that's it for that one. Alright, one more. Problem number 4. Again, at a glance, we know the vertex. It'll be the opposite of this one, and then we just keep that one. So the vertex is going to be -1, 2. Okay, so we'll put that right in the middle. -1, 2. The y values, going less than -1, that means -2 and -3. Going greater than -1, that means 0 and 1. Okay, we could even graph the vertex at -1, 2. So here's -1, 2. We should know right now whether or not this parabola will be facing up or down. Can you tell me that just based on the equation? What do you think? Yeah, this parabola is going to be facing down. You can tell because of this negative sign right here. This is a -1 a value, and that means the parabola will be facing down. Okay, for now let's go ahead and get the actual values that go with this. So let's see. The equation is negative x plus 1 squared plus 2. So go to your table function, and we'll do negative x plus 1 squared plus 2. Hit enter 5 times. 1, 2, 3, 4, 5. Alright, this table starts at negative 3, so let's go ahead and scroll to negative 3. So the y values are negative 2, 1, and 2. Alright, so there's our negative 2, our 1, and there's the 2 that we knew we would find. Now, because of the symmetry of a parabola, we know that this y value is going to be 1, like this one, and this y value will be negative 2, like that one. But it's always good just to verify that looking on the calculator. So there's the 1, and there's the negative 2 that we predicted. So let's go ahead and graph this. Let's see, negative 3, negative 2. So here's, hold on, negative 3, negative 2 will be right here. Negative 2, 1. And because of symmetry, we know we're going to have 0, 1. Okay, because these are mirror images of each other. And we know we're going to have this point right here. 1 comma negative 2. If possible, I like to pull another value off the calculator. Let's see if the next value will fit. So I'll go down, and I see 2, negative 7. That still fits on the graph, so let's go ahead and graph it. Okay, 2, negative 7. Alright, please include these extra values. Always graph as many as will fit. It makes your graph more accurate and easier to draw. Okay, so now this is plenty of values to draw the parabola. So let's go ahead and do that now. Alright, so there's your parabola. Now would be a good time to go ahead and draw the axis of symmetry right down the middle. Alright, there's your axis of symmetry. So all that's left is to answer the questions that they gave us. So the vertex, we've had that since the very beginning, negative 1 comma 2. Is this vertex a maximum or a minimum? Well, this vertex is at the top of this mountain. It's the highest point on the graph, so clearly that is a maximum. Does the parabola face up or down? We knew from the beginning that it would face down because it's negative, it has a negative a value, and we graphed it, and sure enough it's facing down. The axis of symmetry. Alright, is this dotted line that we drew right down the middle. It's a vertical line at negative 1, so we will write x equals negative 1. Please make sure you write x equals. That's not optional. This is the equation of a line. If you just put negative 1, that's not the equation of a line. That's just a number. At best, that's a dot. Not good enough. The zeros are the x-intercepts. We're going to have to estimate on these. The x-intercepts are happening here between the lines, so we're going to have to estimate a little bit. But that's okay, alright? Sometimes life is messy. Now the x-intercepts, let's take this one on the left. It's a little bit to the left of negative 2, so maybe negative 2.4, negative 2.3, something in there. I'm going to say negative 2.4 comma 0. Okay, so that's one of them. Now this one on the right, it's a little bit to the right of 0, so I'm going to call that 0.4. We'll give you a little bit of flexibility here. If you said 0.2, 0.4, 0.5, you know, anywhere in that area, I'm going to give it to you because we're estimating. But I should mention this though. If you say 0, that's wrong. We already have a point at 0, and it's right there in blue. If you say 1, that's definitely wrong. We already have a point at 1 for sure. So the x value you name right here has to at least be something between 0 and 1, but it can't be 0 or 1. So 0.4 comma 0. The y-intercept is very clear. It's right here. The y-intercept, of course, is the place where the graph touches the y-axis. So that is 0 comma 1. You know the y-intercept is always going to be 0 comma something. So you can usually see it right on your chart right here. But sometimes it goes off the graph before it touches the y-axis. That doesn't mean it doesn't exist. There will always be a y-intercept. You can just find 0 on your calculator, and that will give you the y-intercept every single time. The domain is the x values of the graph. So the domain is how far the graph goes to the left and to the right. So because this parabola goes to the left forever and to the right forever, the domain is negative infinity to positive infinity. Okay? In some textbooks, you'll see this referred to as all real numbers. Alright, but we've been preferring interval notation. But I thought I should mention it because you might have to take a standardized test or something where they say all real numbers. Now the range represents the y values of a graph. So how low does this graph go and how high does it go? You have to give me the range in that order, from bottom to top. It's always from least to greatest. So how low does this graph go? Well, it goes down forever. So the first thing you have to put is negative infinity. And then how high does it go? Well, you see it goes up to 2 is the highest value. So it's going to go from negative infinity to 2. The infinity is always get the round parentheses because you can never attain infinity. So we use the round to show that you can't include the infinity, you can't reach it. The 2, on the other hand, the parabola has no trouble reaching 2, so the 2 is included in the set, and we show that with a square bracket. You can even see the 2 is right there in part of the vertex, so it definitely got included. And that's it. That is the end of this video, the end of this assignment, the end of this lesson. I hope it was helpful. I will see you on the next video.